One equation that we're going to talk about here that we can't use factoring on. Of course, we're talking about quadratic equations, and by quadratic equations I mean what type of equations? They are x squared equations, and just some x squared equations cannot be solved by factoring. For example, this one. X squared minus 10 equals 0. This one, if we tried factoring it using the same techniques we've been talking about, can I factor x squared minus 10? Why can't I factor x squared minus 10 as we have been factoring along here? There's no common factor, and it's not a difference of squares either. I mean, if this is x squared, but that's not a perfect square. If that was 100, we'd be in business. We could do that by factoring. But yeah, since this isn't going to factor, that's what we're talking about. We need some other techniques that we can utilize. Now, the one we're going to talk about two of them. The one we're going to use here we'll refer to as the square root method. Let me show you what I mean by that. Let's take another one, and then we'll get back to that one. Oh, let's just start with x squared equals 25. If I have x squared equals 25, hopefully there you can see that there are two answers there. One of them is 5. What's the other one? Negative 5, okay? 5 and negative 5 are solutions there to that. Now, where this technique comes in is how 5 relates to 25. 5 is what of 25? Is the what? Square root. Okay? So 5 is the square root of 25, and negative 5, wouldn't you agree, is negative the square root of 25. Okay? Well, we didn't exactly go through it in direct manner there, but that's what these are. So this, if I can get it something like this, then there's two answers. One of them is the square root of that. The other is the negative square root of that. So if I had x squared, say equals 30, what would the two answers of that be? Well, one would be x is square root of 30, and the other x is what? Negative square root of 30. Yeah. Even though 30 is not a perfect square, it's not square rootable nicely, I can still say, yeah, the two answers here are going to be the square root of 30 and the negative square root of 30. This is going from here to here. That's what I refer to as the square root method of solving these, because here's how it works. Square root method of solving quadratics. If I have x squared equals a number, or something squared equals a number, then the solutions are x equals the square root of that number, and x equals negative the square root of that number. That's my two answers, or the step that I can take, okay? So if x squared equals a number, then the solutions are x equals a number and x equals negative the square root of that very same number. All right? Now, here's another point. What usually we do here on both of these, we can condense both of these answers here into kind of a single expression. You'll see this a lot in this section and the next. The plus or minus notation. we can write those together. Since I've got the plus 5 and the minus 5, we can just simply write the answers as plus or minus 5. This one would be x is plus or minus square root of 30. Okay? So, to kind of, here's kind of the synopsis of that. If I have, and I'll get back to x squared minus 10 equals 0 in just a second. All right. If I have x squared, let's do x squared equals 90. Basically, the idea is I'm going to take the square root of both sides. This is another way maybe to help you remember what to do here. Basically, what I'm going to do is I'm going to take the square root of both sides. The catch is this side could be either plus or minus 90, plus or minus square root of 90. Of course, this the square root and the square cancel, so we just get x equals plus or minus the square root of 90. That's kind of how we're going to denote this little method. Like I said, basically take the square root of both sides. This side could be plus or minus because it needs two answers and it's plus or minus that side. Now, having said that, there's also another little thing here. What else to do here on this particular problem? Don't I need to simplify this? Yeah, this being a square root, you want to simplify those square roots accordingly. That breaks down, what, 9 and 10? Square root of 9, square root of 10, so that'd be 3 square root of 10 plus or minus would be my final answer. Okay? All right, so let's go back to our x squared minus 10 equals 0 problem. If I'm going to use that square root method to solve that one, what do I need on that to do? Yeah, I need to move the 10, don't I? I need it to look more like this. X squared equals a number. And so in this case, I don't want one side 0. I want the other side to be a number. This side, I want to be x squared. So yeah, the first step here is move the 10 over, so get x squared equals 10. Now I square root both sides, basically. And don't forget, if you do it this way, you can write them out, both answers there, but if you do it this way, don't forget the plus or minus. Because we get, those are my two answers, plus or minus the square root of 10. Okay? So there you go. That's how you would do one of these that will not factor. Most of these we've done here won't factor, so this is the way you do those. Okay? Ones like this. Okay, what about this one? 2x squared plus 7 equals 31. 2x squared plus 7 equals 31. Why, on that one, would I want to use the square root method, you think? To get the answer. But why couldn't I just use factoring, do you think? Well, I don't think it factors, does it? For one thing. But the other thing is, this one's a candidate for the square root method is because I can get x squared by itself, can't I? I can subtract 7 here and get 2x squared would equal 24, and then divide off that 2 there, and x squared equals 12. Which pretty well tells me that, yeah, this one won't factor, but yeah, if you can get x squared by itself, and that's the only x term there is, that's a strong candidate for your square root method. All right, so what's next? Yeah, we're going to do square roots here, and plus or minus the square root of 12 side. So we get x equals plus or minus, and yeah, the 12 is reducible there, simplifiable. 4 and 3, square root of 4, square root of 3, which makes it answer plus or minus 2 square root of 3. Okay? Question or any concern? All right. Well, let me show you here another couple of these. So I've got 4x minus 7 squared equals 13. 4x minus 7 squared equals 13. Different ways we can do this one. Here is one way. One way is the square root method. If I square root both sides there, what does that get me? If I square root both sides, if I square root this side, square root that side, the square and the square root cancel, don't they? Just like we've seen in the past. Yeah, so that'll give me simplified 4x minus 7 over here. Now, we are going through here the square root method, so what about this side? There is two answers there. One of them is plus or minus square root of 13. Or one's the square root of 13, the other's minus. So yeah, we can do this one utilizing also, even though this side looks a little different than this, we can still use this square root method to solve this, because now we get down to a simpler version of the left side there, you see. Now, there's a little more here to do. What would I do to go ahead and finish this out? I'll need to move the 7 and the 4 over, so how would I move the 7 and the 4 over? Well, to move the 7, I would add it, right? Add 7 to both sides. Let's talk about that. Add 7 to both sides. Anything combine on that right side? No. I've got a square root term and I've got a regular just number, so no, those don't combine. I just have to say 7 plus or minus the square root of 13. And so then last but not least, divide by 4. And so that's my two answers there. And that is another another point that I'd like to make is that yeah, these are all x squared equations or y squared quadratic equations, and always on quadratic equations I should get two answers. And so realize here that there's tied up in here two answers. I've got two answers here, got two answers here. Now this one looks a little different than these. It's got a lot more stuff on it, but there are two answers there. It's 7 plus the square root of 13 over 4 and 7 minus the square root of 13 over 4. That would be two different values. With me on that? Quadratic, there's two answers. Yes, the plus or minus stays with the square root. That's right. It's plus or minus this square root. Yeah, it doesn't go with the 7 or anything else. That's right. All right, similar here, but let me show you one other thing. 5x plus 4 squared equals 9. This one simplifies even a little bit more than the previous one there. But it's a similar deal. To get rid of this square, that's kind of the cue there, got a square root it to get rid of that square. So I'd square root this side though, don't forget the plus or minus. So what happens is simplifying here, the left side's 5x plus 4, and then the right side, well, that simplifies too, yeah. Yeah, if you can simplify your square root, I didn't have one that simplified on the other one, but yeah, square root of 9 simplifies. If you get a square root of 12, you want to simplify it. Anything like any other square root, you want to simplify it if you can. All right, well, that being then plus or minus 3, I'm going to subtract 4. So you get 5x equals negative 4 plus or minus 3. Then divide by 5. So I get negative 4 plus or minus 3 over 5, which is a pretty good answer. However, I can simplify it just a little bit more, can't I? Yeah, because this is 3 here, I can, like I did with those, if I write those out separately, negative 4 plus 3 over 5 and the negative 4 minus 3 over 5, I can go ahead and get just some regular numbers out of that. Negative 4 plus 3, that gives me negative 1 over 5. Negative 4 minus 3 gives me negative 7 over 5. So that one works down to just some nicer fractions than we've had previously there. Okay?